Hello and good morning, CSI257 students at Anne Arundel Community College for the fall 2014 semester for the Scaling Networks course, which is the third of 4 courses in the Cisco Networking Academy curriculum. Today's PacketTracer activity is going to be a tutorial on PacketTracer 2.3.2.2, where we're going to be doing almost the exact same thing we did with PacketTracer activity I think it was 2.3.1.5, where with PacketTracer activity 2.3.1.5, we went ahead and implemented the per VLAN spanning tree, or per VLAN spanning tree plus, since we're on a Cisco switch and we've got 802.1q trunks. And so this activity, 2.3.2.2, is simply going to cover the rapid per VLAN spanning tree implementation. So the topology is a little different, but the steps are going to be very similar, and the most important point of this video is to cover one more time sort of the history, the most confusing part of the history of the spanning tree protocol, because for a lot of students, especially first-year students or networking students who are new to networking and Cisco, spanning tree, and specifically all the variations of spanning tree that are out there, can be extremely confusing. And so my explanation on my previous video, I listened to it again, listened to it back, and wasn't very happy with it. So wanted to go ahead and provide some additional information and sort of clarify some things. So one of the first things that we want to talk about is, from a timeline perspective, is really 1985. So in 1985, at the Digital Equipment Corporation, or DEC, which is no longer in existence, there was a woman by the name of Radia Perlman, and I hope I get this right. Radia Perlman, there we go. Radia Perlman, and she alone created what was known at the time, or what was known then as spanning tree protocol. Now, what's interesting is that it was really referred to as sort of DEC STP, right? Because she was working at DEC, it was obviously intellectual property there, so it was referred to as DEC spanning tree protocol, right? And so this was when it was created, okay, in 1985. And if you're keeping the timeline straight, right? Cisco at the time, Cisco was 1 year old at that time. I believe they were founded in 1984. So you have to then go to 1990, right? Which is going to be sort of the next marker date. And that's when DEC went to the ITripleE and went to get spanning tree standardized, right? So the ITripleE becomes involved in 1990. And basically, the DEC spanning tree is submitted to the ITripleE, and at that point, the ITripleE took it and they changed some of the timers, right? Made some minor modifications to it, and then stamped it as an ITripleE standard, and a standard protocol with the ITripleE. And in 1990, it came about that it was 802.1. That's a terrible one. Sorry about that. .1D, right? In fact, now we'll leave it up there. So 802.1D in 1990 was the standard that was published. And so again, everyone initially was just calling it the spanning tree protocol, or the DEC spanning tree protocol. When it was first published by the ITripleE, it was referred to as 802.1D. Now, there's no dates here that follow this initially, right? It was just simply 802.1D. And what ended up happening is there were 2 subsequent versions of the protocol that the ITripleE published. The next was going to be in and we'll go to 1998 here. There's going to be some things that happen in between, where the ITripleE came out and said, all right, we're going to have the 802, and let's see if we can get the 1 right here. It's going back, it's killing me. 802.1d, and this was going to be the, excuse me, 1998, right? 802.1d, 1998. And so they updated the standard, right, in 1998, and we're going to do this a little out of order here. So it was in 1993, I believe. Yeah, September of 1993, when Cisco, and remember, prior to 1993, Cisco had no switching line. So they actually ended up buying Crescendo, and it was Crescendo Communications. And they gobbled them up for their switching product line. So it wasn't until 1993 that Cisco actually got into the game. So 85, Rodio Perlman creates a spanning tree protocol while working at DEC. In 90, the ITripleE publishes the first standard. So then 93, Cisco gets involved, and they actually buy up Crescendo Communications, and they start working on their own version of spanning tree. So this 802.1d was commonly referred to as the common spanning tree, or CST, and MST, or mono spanning tree, right? So these were two acronyms, and that broke out into names, that the 802.1d standard was referred to as. So it was the common spanning tree, or it was mono spanning tree. So it was common and mono. And the reason I'm writing this out is because the MST, right, and this is where it can get confusing. So multiple spanning tree, which is actually very popular today, often goes by this exact same acronym, MST. Sometimes you'll see MSTP, but again, it can still be confusing. So common spanning tree, mono spanning tree, right? And that was what they initially called the 802.1d. Okay, so we're going to come back to the 98 here. I actually should have held off on this, but we'll leave it up in here for right now. So 93, Cisco buys Crescendo Communications, and they start work on their own version of the spanning tree protocol. And so what ended up happening was the drawback of the common spanning tree and the mono spanning tree, right, the 802.1d standard, was that you could only support one instance of spanning tree for all of the VLANs that you would create. And so the problem with that is that it doesn't allow you to do any kind of layer 2 traffic engineering. And so what I mean by that is if we had a switch here and a switch here and a switch here and a switch here, say there's another one over here, and these switches connect like this, right, and maybe this guy goes up here, there was really no way to force the traffic or manipulate traffic to go one route or the other route. You had a single common spanning tree instance. So again, to clarify, you could have multiple VLANs. That was never a problem, but you could not, you had a single instance of spanning tree. And so that's when Cisco said, and remember, Cisco's trunking protocol was ISL, right? And that was the proprietary Cisco trunking protocol. So it's proprietary Cisco, and this is what they were using, and they came up with per VLAN PVST. I apologize, I'm trying to spell it out. They came up with PVST, right? Per VLAN spanning tree. Okay, now the only drawback with PVST was that it only ran on with ISL trunking, right? So Cisco's proprietary version of spanning tree that they came out with was PVST. You'll notice there's no plus sign here right now. So just PVST. And the drawback was that it would only work with the Cisco proprietary interswitch link ISL trunking and trunking protocol, right? And so this became a problem because it would not work with the standard that would come out shortly thereafter, or a little before that, was 802.1q, right? So the 802.1q standard was for trunking encapsulation, and that's also where, if you look at the standard, the common spanning tree, or CST, is also defined under the 802.1q standard. Now, the problem was that the PVST version of the Cisco spanning tree protocol did not work with 802.1q, right? So in order to come up with a version that did work with 802.1q, and again, the common spanning tree only supported a single instance of spanning tree for all of the VLANs that you were running at that time. And so what ended up happening was Cisco decided that they were going to go ahead and take the 802.1d, right, the original CST MST standard, modify it, right, or modify their per VLAN spanning tree, and they came out with what was called PVST Plus, right, or per VLAN spanning tree plus. And the key is this PV, per VLAN. So whereas with common spanning tree, right, you had a single instance of spanning tree running on for all the switches in the entire bridge network, you had one instance of spanning tree. Cisco said, we want to be able to do traffic engineering, so we're going to go ahead and create a per VLAN. So that means that there's a single instance, right, per VLAN. And so let me rephrase that. Maybe a little better way to say it is, for every single VLAN, you have an instance of spanning tree running for that VLAN. So for example, if I had, in this terrible drawing over here, if I had VLAN 10, 20, and 30, every single one of those VLANs has its own per VLAN spanning tree instance, right? So one for 10, one for 20, and one for 30. And in the previous video, we saw this when you ran the show spanning tree command. That's why each VLAN had its own little section that would describe how it views the spanning tree. And we were also able to manipulate the traffic, and excuse me, who would be the root bridge, who would be the root bridge, and who would be the secondary bridge. And so we were able to manipulate or do traffic engineering at layer 2. So as I said in the first video, the plus sign, right, really what that plus sign represents, and this is where a lot of students become confused, because you'll see PVST in the command line, right? This is what you see when you're on the CLI. You'll see this in a lot of documentation sometimes, but then you'll also see this PVST Plus, and students commonly make the mistake to think that, oh, so there's PVST, there's PVST Plus, there's rapid per VLAN spanning tree, RPVST Plus, and then there's RPVST or RSTP. So, and we'll cover that in just one second. But again, really, that plus sign, all this plus sign indicates is that it supports spanning tree over 802.1q trunks. Okay, so this is what happened initially. Was Cisco was using, again to recap, Cisco was using ISL as a proprietary protocol, and they were running per VLAN spanning tree. And then the ITripleE came out with the 802.1q standard. It had previously been it was always 802.1d, still is, and then 802.1q again further defined the common spanning tree, but 802.1q said, well, we can send multiple VLANs across a trunk link, right? So the PVST that Cisco had that worked only with ISL does not work with 802.1q. So then Cisco basically said, we're going to have a PVST Plus, right, which allows that traffic to transit the 802.1q trunk links. Okay, and so let me kind of draw some lines in here for some key for some key points, right? So that's sort of the PVST PVST Plus story. And then again, the same thing happened again. So remember, we had set up here that we have the 802.1d was the original draft in 1990 and 98, right? They came out with 802.1d 1998. And then it was in 2004 where the ITripleE came out with an update, right, to the preceding standard, which was that 1998 standard, and it was 802.1d 2004, right? And so it was at this time in 2004 when a lot of the shortcomings of the common spanning tree in terms of convergence time, in terms of some of the spanning tree tools that you could use. So the 802.1d 2004 standard, which rolled in the 802.1w into it, is commonly referred to as Rapid Spanning Tree Protocol, or RSTP. Okay? And I'll put down the 802.1w underneath. And so the 802.1w, which was that Rapid Spanning Tree Protocol, got rolled in to the 802.1d 2004 update, and Rapid Spanning Tree Protocol added in quicker convergence times, right? So with the legacy spanning tree, you would have to go through the listening, the learning, right, and then get to the forwarding state eventually. And this could take anywhere from 30 to 50 seconds, right, to transition between all these states. And so the Rapid Spanning Tree Protocol shortened that time and also changed sort of the port states, right? So for Rapid Spanning Tree Protocol, our port states were discarding, and then you had learning, learning, and then you had forwarding. Terrible R, right? Whereas previously you had the list. You started with disabled, right? You had the disabled state. You had the blocking state, and then you had listening, and then you had learning, and then you had forwarding. And so this is sort of, these guys here kind of make up the legacy spanning tree. And the reason that it's legacy is because on a lot of the newer Cisco switches, you will see that the default leverages the Rapid Spanning Tree Protocol. So again, and this is something to take note of, again, just like the common spanning tree, right, or the original spanning tree pro, that 802.1d, the 802.1d 2004 standard that used 802.1w Rapid Spanning Tree Protocol still only supported a single instance of spanning tree for all of the VLANs, for the entire architecture, right? So you had one instance of spanning tree running, even though you could have multiple VLANs, it was still a single instance of spanning tree. And so Cisco saw this again and said, we need to be able to traffic engineer. And so Cisco said, well, we're going to go ahead and we're going to do Rapid per VLAN Spanning Tree Plus. And again, that plus is to support the 802.1q trunks, right? Because at the time this came out, Cisco was still using ISL, right, as a proprietary protocol for trunking encapsulation, okay? And so the key here is this rapid, so it stands for Rapid per VLAN Spanning Tree, right? And you could even think of it as the R breaking out, and again, this isn't official, but Rapid Spanning Tree Protocol per VLAN Spanning Tree is a good way to try to remember it, right? Or just RPVST Plus. And the key is this, again, per VLAN. So with Rapid per VLAN Spanning Tree, right, Cisco's version of it, it was an per VLAN, you had an instance of the spanning tree protocol. And we're going to see that here in PacketTracer 2.3.2.2. And that's what we're going to be doing here in a second. And so it also added support for the BPDU version 2 with the rapid spanning tree, whereas the originals were using BPDU version 0. So that's really why you see the plus sign in a lot of the writing, and that's also why Cisco continued to press for per VLAN spanning tree capabilities, was the idea of, again, being able to use or being able to do traffic engineering, where you can control which switch is going to be the root switch. You can control which switch is going to be your secondary switch, so that you've got deterministic failover in case your primary fails. And again, the shortcoming of the rapid spanning tree protocol, there were a lot of enhancements, right? Faster convergence, fewer port states, so forth and so on. But again, it only supported one instance of the spanning tree protocol, right? So you could have multiple VLANs, but only a single instance of the spanning tree protocol. And then the final one that we'll talk about here, and so that's the rapid spanning tree protocol and the rapid per VLAN spanning tree. And that's what those plus signs mean, right? So then you have, and sometimes this is where it kind of gets confusing, is MST, right? And so this is referred to commonly as 802.1s is the standard, and it was incorporated into the 802.1q 2003 update, right? So remember, we said that we had 802.1q came out, right, and they kind of defined spanning tree, or the common spanning tree initially, right? So this 2003 update included 802.1s, which is multiple, right? Multiple spanning tree. It is not what was commonly referred to at the very beginning here, mono spanning tree, right? This is a legacy term right here, and today when you hear MST, it stands for multiple spanning tree, and sometimes you'll even see this as multiple instance spanning tree or MIST. But more often than not, and in a lot of the Cisco documentation and the certification curriculum, you'll see either MST or sometimes it's even MSTP. So you can see why it becomes confusing, right? But 802.1s is referred to as MST, and again, it basically takes the rapid spanning tree protocol and allows you to go ahead and do multiple instances of spanning tree, and it gets a little more complex than that even, right? So, but that's what MST is. And again, remember that the Cisco PVST Plus runs on 802.1q trunks, and PVST, which is the rapid per VLAN spanning tree, will work with the ISL. And so today, right, remember I had mentioned that ISL has been decremented, right? It's dead. You'll see it in a lot of the legacy environments. It's still around. It's a configurable option in legacy environments. But going forward, you won't even see ISL as an option when you go to select your trunk and encapsulation. It'll always be 802.1q. And so by virtue of the fact that you're doing 802.1q trunks, you would be doing PVST Plus, or if you chose to, you would be doing PVST Plus. And that's what that plus sign means again. Now, realistically, there's really no reason to be running PVST at all, right? Because if you've got access to the rapid spanning tree protocol, and that's a capability, you would probably want to run that, unless for some reason you need to have long timers and not have all of the features that have been rolled into the rapid spanning tree protocol. Okay, So I'm hoping that that provides a more clear definition of the spanning tree protocol and the history of the spanning tree protocol. And again, it all started back in 1985. And for those trivia people out there, Radia Perlman is also referred to as the mother of the internet. All right, but she created the spanning tree protocol while working at DEC. And so hopefully that clears up what that plus sign means, what the different versions are, and the fact that the standard, the 802.1d, right, and then the 802.1 D 2004, so the 98 and the 2004, the RSTP and the common spanning tree, it is a single instance, one instance of spanning tree running for all VLANs, and you cannot do traffic engineering that way. All right, so let's go ahead and jump into the activity here and see if we can't knock this out very shortly. I'm going to take a quick pause here. I'm going to get something to drink, and I'll be right back. All right, so we're back, and we've gone over sort of a history of the spanning tree protocol, and now we're going to go ahead, we're going to jump in here to the activity that stands before us, which is we're going to be configuring the rapid spanning tree. It's interesting, it says configure rapid spanning tree PVST Plus load balancing. So again, we're going to see it as RSTP, but we know that it is going to be Cisco's RPVST Plus, so the Rapid Per VLAN Spanning Tree Plus, right? And so let's go ahead and jump in here real quick and knock this out. So the first step is to enable the switch ports for the access mode on switch 2. I'm trying to get this to go down just a little bit here. Can we see by it? All right. And we know that these, just like the ones yesterday, are going to be set up with PortFast, the spanning tree feature PortFast, as well as BPDU guard. So if I were to go ahead and go from user exec into privilege exec and then into global config mode, what we're going to see is we need FA0611, and so we'll do 06 first. And something that you could do that might make this easier, again, I did this the other day, and I'm looking here, I don't see, let's go ahead and we'll type in Notepad, and we'll bring Notepad back up. And Notepad's going to come up here shortly. Alright, so we'll shrink Notepad down a little. And this is something that you can do to make sure that you can actually recreate your configs rather quick. So if I were to type in here int fa0/6, and then we're going to do switch port mode access, switch port access VLAN, and I believe it's going to be 30, and we'll double check that. It's hidden there just a little bit. And then we're going to do spanning tree PortFast, and we're going to do spanning tree BPDU guard enable, and then we're going to do no shut. And we could actually do this for all of the ports that we have ahead of us. So if I were to highlight that and copy, and then come down here and edit paste, and edit paste, all we'd have to do now is change the port number. So we'll do 11, and we're going to make it port 18. So let me make sure we're going to change the VLAN as well. So yep, VLAN 30, VLAN 20, and lastly VLAN 10. And so let's try this here. Let's make sure we've got this right. We're going to select this. I actually think it's already in the buffer. Copy, and we'll come over here. I'm going to exit out one level, and we're going to go ahead and paste this information in. Alright, so we've got our switch port mode access command. We've got our access VLAN 30. It creates it. Spanning tree PortFast has been turned on. And it looks like we have a mistake there with the BPDU guard. Let me make sure. So if I do spanning tree and then Did I get that right? BPDU, oh, BDPU, yes. And as you can see, I've propagated the error twice here. So BPDU and BPDU. And I might as well fix it up here too. BPDU guard. All right, so that's what we're looking for. So spanning tree, BPDU guard, and enable. And then finally our no shut. And this is going to save us some time. All right, so port 6 has gone to the upstate. We can see just right out of the corner here that it's green and green, right? So we're good there. All right, so now let's go ahead and let's jump into interface FA0/11. And actually, don't even need to do that. I can just exit out one level. We're going to grab our config from Notepad over here. And whoops. And we're going to grab our config here and say edit copy, and then we're going to come over here and we're going to drop it down and paste it. So we're done there. And then we can just go up one level. And last but not least, we'll grab FA018. So we're going to copy that. We're going to come up here and we're going to paste that in there. All right, so those three interfaces are done. So if I do a show run, we should see, do show run, we should see VLAN, Fast Ethernet 06 is in VLAN 30, and we've got our spanning tree all set up there, and 11, VLAN 20, and Fast Ethernet 018, VLAN 10. So things look good from that perspective. Now, we also know we have to create a series of VLANs here. 10, 20, 30, 40, 50, 60, 70, 80, and 99. And again, the recommendation would be to go ahead and create those in one command line. Unfortunately, PacketTracer doesn't support that feature. So we're going to say VLAN 10, VLAN 20, VLAN 30, VLAN 40, VLAN 50, VLAN 60, whoops, VLAN 70, VLAN 80, VLAN 90, VLAN 99. Okay, so this should allow us to create those VLANs. So let me grab that text and we're going to say copy that. And so that needs to be done on all three of the switches. So we're going to go ahead, we'll do that first here, and we'll drop it on switch 2 to make sure that everything does what it's supposed to do. Right now, again, remember, when I do a do show VLAN brief, we're going to see that those VLANs are there. But remember from my previous video that if you were to do this, run those commands on an actual Cisco switch, and here's, actually we're probably going to have to get, let's get switch 2, actually switch 4. So we have switch 4 here, which does not have those VLANs on there. So let me exit out, and if I were to go ahead, and paste that information in here, oh whoops, it's got something else here. Make sure I can copy between these two, copy, and let's see if it's going to allow me to paste it. It's not. So we'll go ahead and we'll do VLAN 10, we'll just do a couple. VLAN 20, VLAN 30, VLAN 40. If I do a do show VLAN brief, right, and this is, again, this is an actual Cisco switch, so 10, 20, and 30, it looks like those were already in there. So, but you'll notice we did 40, and 40 does not show up. So it's not until I exit from VLAN configuration mode and then do the do show VLAN brief that I'm actually going to see VLAN 40, and now it does show up. And so I apologize because it looks clear that 10, 20, whoops, that these three guys here already existed, 10, 20, and 30. So they were already there. But you could see with VLAN 40 that it did not show up, and I'm having a terrible time with the pen today. You could see that VLAN 40 did not show up until we exited, right, when we did the exit further up from VLAN config mode back to global config mode. Okay, so let's jump back, let's clear that, and we'll jump back in here. So we did that on switch 2. Let's go ahead and pull up switch 3, and we'll get the CLI up for, whoops, we don't want that. CLI for switch 3, and again, we're going to go from user exec into privilege exec, and then into global config mode, and I'm going to go ahead and paste these guys in right now, and so then there's all of our VLANs. and we're good on switch 1 or switch 2 already, so we'll come over here to switch 1, and again from user exec into privilege exec, and then into global config. And I'm going to go ahead and paste those same commands in here. All right, so we've got all of our VLANs created here. Assign VLANs to switch ports, right? So we've done that already up here where we had the switch port assignments that we had to make. You could see that we've done that. So on switch 2 was where all of that was done, and here were the VLAN assignments. So that's been taken care of. So let's go ahead and continue on. Verify the VLANs, we did. So assign the trunks to native VLAN 99. It says use the appropriate command to configure FA01 to FA04 on each switch. Whoops. We'll drag this down. To each switch to VLAN 99. So we're going to do this again, right? So we could do this, so we could just simply cut and paste it. We're going to be typing in interface range FA0/1 to 4, and then once we're in the interface range configuration, I like to go ahead and we'll get the no shut right in there, and switch port mode trunk, and switch port trunk VLAN allow, or I'm sorry, switch port trunk, and my memory is failing me here. I believe it's native VLAN, but let's find out real quick. So on switch 1, if we do int range FA01 to 04, then we're going to do a no shut just to make sure. We're going to do switch port mode trunk, and you can see we've got trunks now on all of those ports, and then it's switch port trunk, is it native? Yeah, native VLAN 99. Alright, so if we were to come back over here to our Word document, we've got switch port trunk native VLAN 99. Whoops. Alright, and then we would do a do write mem. We'll throw that in there just to be safe. Save our configuration. We haven't done that in a while, so let me grab what we have here. We're going to edit and then copy it. And you can see we're seeing our native VLAN mismatch again, right? Which we would expect. So let's come over to switch 3 and see where we're at here. So let's exit out to global config from VLAN config, and let's paste in what we've got and see what happens. Right? So there we go, and consistency has been restored. It happened awfully fast. So VLAN, or I'm sorry, switch 2 out of VLAN config mode, and let's paste in. Whoops, let's paste in our config here, and there we go. Switch port mode trunk, and we're good, right? So just on switch 2, if I were to do a do show show interface trunk, right, we can see that, whoops, you can see that the native VLAN has been set on all 4 ports, right, FA1, 2, 3, and 4. The mode is on. Okay, and that's a little outside the scope of what we're talking about, but just know that we've hard-coded it so that it's a trunk port. And here's a very important point here, that the encapsulation is set to 802.1q, right? And this is PacketTracer is doing this for us, right? On some legacy switches, you have an option to put in either ISL or 802.1q, and the status for all 4 ports is trunking, right? Okay. So we're going to go ahead and clear that off and drop out of that mode. All right, so what do we have next? What's next on the agenda? So we've got VLAN 99 has been assigned. Configure the management interfaces on all 3 switches with an address. So that management interface is going to be VLAN 99, and it looks like in this exercise, so switch 1's 11, 12, and 13. So we'll be able to do that from right here. So we'll start with switch 1. Right, and let's go ahead and do interface VLAN 99, and it's up. I always like to do no shut just to be sure, and then IP address 172.31.99.11 and 255.255.255.0, and then we're going to go ahead and we're going to jump over to switch number 2 and do that same thing. So int VLAN 99 no shut, and IP address 172.31.99.12, 255.255.255.0. All right, so switch 2 is done, and then we'll jump over here to switch 3. And so we're going to go int VLAN 99, no shut, IP address 172.31.99.13, 255. All right. So now if I were to do a do ping 172.31.99.1 and I'm sorry, .11 do ping, it didn't like that command. Translating 172.31.99.11. I'm wondering if I have a typo. I don't see a typo in there. Let me swing back over here. So I was trying to do a domain translation. Let me check something real quick here. And we've got the interface has been configured. We're going to configure. So let's go ahead before we confirm that. We're going to go ahead and configure. And actually, we should not have to do that. And Control-Shift-6. It's not getting us out of there. So let's see. So it looks like switch 3 is having some issues here. So let's come over to switch 1. And let me double check and make sure that we've got the IPs are correct. 172.17. Okay. So let me go ahead and resolve that issue here. That may be what's hanging PacketTracer up on switch 3. So we're going to go ahead and do no and VLAN 99. And so we'll do IP address 172.17.99.11 and do show run. And let's make sure, okay, 172.17.99.11. So switch 1 has been fixed, and we'll come over here to switch 2. And let's see what switch 2 says. So we'll say IP address 172.17.99.12. Whoops. Let's get our subnet mask in there. All right, so if I do a do ping 172.17.31, I'm sorry, 99.1. All right, better results here on this command. And that's what we wanted to see. It's ARPing out, so still nothing. And let me check on switch 3. All right, switch 3 is back. So let's do IP address 172.17.99.13. Do show IP interface brief, and our VLAN interface is here at the bottom. So 172.17.99.13. Let me double check that. Make sure I'm not transposing anything. 172.17.99.11, 12, and 13. All right. Yeah, that should be good. Okay. So we're good there. So if I were to go ahead on switch 3 and type exit, let's actually type in, do a write mem. So if I ping 172.17.99.11, let's see what happens. Do we have connectivity? We do. What if I ping 12? Do we have connectivity? It's going to ARP out. That's why you're getting the dots, the failures, and then it works. And so then the subsequent pings are going to succeed. All right, so switch 3 is back up, thank goodness. Okay, so we've configured the management interfaces, we've verified connectivity, and now we really get down to the crux of this exercise, which is configuring rapid per VLAN spanning tree plus, right? But we're going to see it as RSTP on the switches. And so use the spanning tree mode command. So let's do that on all 3 switches. And I'm going to move these over to here for now. So switch 2 I'm going to bring down over here. And then, whoops. Okay, and then switch 3 I'm going to bring down over here. All right, so if on switch 1 I start out by saying, exit out here, so spanning tree mode, and if I do a question mark, you'll see we have 2 choices. Per VLAN spanning tree and rapid per VLAN spanning tree. And let's remember that the per VLAN spanning tree, right? So this is actually 802.1d, right? This is going to be, it's Cisco's implementation of a per VLAN, right? Whereas the original 802.1d, as well as the rapid spanning tree, it was one instance of spanning tree, one instance of the protocol running for all of your VLANs, and no traffic engineering. And so per VLAN spanning tree is going to allow us to do traffic engineering, because if you look over here, that's exactly what we're doing here. So when you see this load balancing, right, at the CCNA level, they're going to call it load balancing, but really what you're doing is TE, or traffic engineering, where we're saying at layer 2, hey, switch 1 is going to be the primary route for these VLANs, and switch 2 is going to be the secondary route for these VLANs, and you have switch 3 over here, right? So we're doing layer 2 traffic engineering. And PVST, again, is the per VLAN spanning tree, but this is legacy, right? So PVST is legacy. It was Cisco's original spanning tree implementation. So the new implementation, which is the rapid per VLAN spanning tree, is rapid PVST, right? And this corresponds to rapid spanning tree protocol, or RSTP. And so if I were to call back up here real quickly, the sketchbook, where are we at? And boy, this got busy in a hurry. You could see that the rapid spanning tree protocol was here, 802.1W, right? And this was that's the protocol, and then it was rolled into the 802.1D 2004 ITripleE standard. So this is the new standard version, but again, that standard version, same thing, only supported a single instance of spanning tree, right? So let me, whoops, sorry about that. Let me say cancel. We're going to drop back over to here, pull the pin back up. Let's clear that out. So again, this is what we're configuring on this PacketTracer's rapid PVST, which is, that's Cisco, what they call it. Rapid spanning tree protocol is actually the standard, and it's interesting, when we apply this, you'll see that it's going to reflect RSTP as the protocol. It would reflect ITripleE as the protocol if it was PVST. And then you'll see, we'll do the show spanning tree summary, and hopefully it's going to show what I know it shows down here in the regular Cisco iOS. All right, so let's clear our screen and let's get back. So our spanning tree mode for today is going to be rapid PVST, and so that's what we're going to implement. So if I do a do show spanning tree, you'll see that it actually shows us that the spanning tree protocol that is enabled, right? The protocol is rapid spanning tree protocol. If I were to run a command that I hope is here, and let me actually click back in here. I hope the command is here. I'm looking for the command, which is do show spanning tree summary. All right, and it is, and this is fantastic. And you could see when you do that show spanning tree summary command, the mode is rapid per VLAN spanning tree, right? And we know that it's our PVST Plus because we are using 802.1Q trunks, right? So if I were to do a do show int trunk, you can see the encapsulation is .1Q for all of them. All right, so let's go ahead and not only make that change, but it says configure switch 1 to be the primary for VLANs 1, 10, 30, 50, and 70. And so the way that we're going to do that is we're going to go ahead and say spanning tree VLAN, and we can do a range here, thank goodness. So 1, 10, 30, 50, 70. And this is where we're going to say, we could use priority, but we're going to say root primary, right? And that's a macro command. So when I do show run, this is the result of the macro command, right? That right there is the result of that command that we just ran, runs a macro in the back, which literally runs the priority command and just drops this priority in for us, right? And remember, that priority is going to be in increments of 4096. Okay, so we're good on switch 1. Let's pull up switch 3. And on switch 3, we're going to say global config mode, spanning tree mode, and we're going to choose rapid PVST, right? So when I do the do show span, and actually Real quickly, let me change that. I wanted to show something before I ran that. So if I were to say PVST and do a do show spanning tree, you can see where at the top here, it's going to show the protocol as ITripleE, right? Because again, per VLAN spanning tree, PVST, that is a Cisco creation, and that is what Cisco is doing, but the protocol itself, right, is compatible with the ITripleE standard, right, which was the 802.1d. Okay, so let me get rid of that. Whoops. Okay, so it would show ITripleE, but we're going to do rapid PVST, and that's where you're going to see RSTP, which is that 802.1w standard that is rolled into the 802.1d 2004 ITripleE publication. All right, so that's been set. So now switch 3 is going to be the primary, so spanning tree, VLAN, and we can do a range here, so 20, 40, 60, 80, and I think 99 are included here. And we're going to say root, and again, it's going to be primary. So switch 1 is the primary for the odds, switch 3 is the primary for the evens, and now switch 2 is going to be the secondary for everything. So let's go ahead and pull up switch 2. And we're going to say exit and spanning tree, VLAN, and we're going to do all of them. So it's going to be 1, 10, 20, 30, 40, 50, 60, 70, 80, and 99. And this is going to be root, and it's going to be secondary. And there's an interesting thing that will happen here. And again, that command is running a macro. So when I do the do show run, you'll notice that we said secondary. So the macro takes a look at the environment and says, what's the primary root priority? And we know that that was 24576. It adds 4096 to that, and that's where it comes up with this number, this 28672, right? So it looks at the environment. It says, hey, all of these VLANs that I'm trying to set my priority for already have a priority set on switch 1 and switch 3, and that priority is, and let me make sure I always get that number. Where are we at here? So do show run, that's 24576, I believe. Try to remember, yeah, 24576. So on switch 2, it sees that these VLANs are already accounted for on switches 1 and 3 with a priority of 24576. So then it adds 4096 to that because we're saying, hey, we're the secondary root bridge for those VLANs. And so again, priority lower is better in terms of becoming the root for those VLANs. So higher is worse or not as good. Okay, so we've got those added in there. And let's see, we do the show spanning tree. We've done that, the port facet configuration. So let's check our results right now. So it looks like we're 3 points short, and let's see, we may have a typo somewhere. Looking pretty good. Access, switch port mode, access. Did I leave that command out? Access, oh, the access VLAN is incorrect on switch 2. So it looks like my cut and paste might not have done what I thought, and it looks like I need to change the mode to rapid spanning tree on switch 2. May have forgotten that. All right, so that's always a good thing to check. Let me drag this back over here, and let's take a look at switch 2 real quick here. So you can see right above where it listed out the VLANs, we are still PVST, so per VLAN spanning tree. We need to fix that, right? And I forgot to run that command, so let's make that happen. So we want to do spanning tree mode and rapid PVST. Well, it should give us another point, so we're at 98. So let me go ahead and double check here on the do show run. Let's make sure that we've got the ports, switch port mode access. So FA06 is VLAN 30, that's correct. Ah, I see the problem. Okay, so 18 came before 11. So let's go ahead and fix that. So let's go into int FA0/18, switch port access VLAN 20 for 18, and then we're going to go into interface FA011, switch port access VLAN 10. All right, and that should do it. Okay, so we are at 100%. So again, the first video, I apologize, wasn't very happy with the explanation of the history of the spanning tree protocol, which is extremely important. So I wanted to make sure I redid that. Here's what we had. It was a mess, right? It ended up being a mess, but hopefully the key points came through, right? That plus, that's when Cisco is saying, hey, this supports 802.1q trunking. And what it's doing is, or what it used to do is encapsulate the traffic across those 802.1q trunks so that the trunk really had no idea what was going across it. So again, quick recap, 1985, Radia Perlman, when she was working at Digital Equipment Corporation, created the spanning tree protocol, right? They called it DEC STP. In 1990, the ITripleE published the first publication on spanning tree protocol. It was referred to commonly as a common spanning tree or mono spanning tree. In 98, an update came out, so 802.1d 1998. In 93, Cisco actually got into the game and procured or bought out Crescendo Communications. They worked with ISL, right? So Cisco's trunking protocol was ISL. The ITripleE and the standard, and what has stood the test of time and what's the standard today is 802.1q, and common spanning tree was defined inside this 802.1q standard. And that's when Cisco said, we're doing per VLAN spanning tree, right? Because we want to be able to do traffic engineering, whereas the 802.1q standard, or I should say the 802.1d, right? And what came out in the original 98 as well as 2004 would only allow you to do a single instance of spanning tree for all of your VLANs. You couldn't do traffic engineering. So Cisco said, PVST only works with ISL, so we're going to throw a plus on the end. PVST Plus is what we're going to call it, and that's going to work with 802.1q. And again, it literally just encapsulated it. Then in 2004, the ITripleE updated the standard, the 802.1d, 2004, and they included 802.1w, which was the new rapid spanning tree protocol. We ended up with some new port states, right? Discarding, learning, forwarding, whereas the originals were disable, blocking, listening, learning, forwarding. And then Cisco said, hey, well, we're doing rapid per VLAN spanning tree plus, right? Or rapid per VLAN spanning tree. We're going to throw a plus there. And it's really just basically running an individual instance of rapid spanning tree per every VLAN, and they throw the plus on there because it works with 802.1q, and that's how you can, that's kind of what the plus sign ended up meaning. And then today, and what's becoming sort of more popular, is the multiple spanning tree, MST, which is 802.1s, right? It's part of the 802.1q 2003 standard, and sometimes you'll see it as MSTP. You can see it as MIST or MST, but be aware, right, when it's being referred to, you can see it as all three of those, but just note, right, that the important thing here is, and we'll go to red. All right, do I have red? Uh-oh. All right, I've got red. So remember, the important thing is that that MST is not the MST that was originally referred to as mono spanning tree, right? Cisco, I think, originally they were calling it mono spanning tree. That is not what this version of MST is today, right? This is multiple spanning tree. And again, outside the scope of your CCNA curriculum, but just want to make sure that you're aware of that. Okay, so that was PacketTracer Activity 2.3.2.2, where we enabled rapid per VLAN spanning tree plus on our switches. We've got our environment looking good, and we're at 100%. Okay, I really appreciate you guys taking the time to watch this video. Again, I hope that this was a better clarification on the history of spanning tree as well as how it ties in with this activity. All right, best of luck to you out there, and have a great day.